Welcome back to the Deep Dive. We have a massive stack of research today, and honestly, the timing couldn't be better. I want you to use your imagination for a second. We're virtually transporting ourselves a little bit into the future. Specifically, it's January 2026. We're standing in the middle of the Metro Toronto Convention Center. The music is thumping, lights are low, and the Canadian International Auto Show is kicking off. Now, usually when we talk about car shows, we're expecting reveals from the usual global giants, Detroit, Germany, Japan. But this year, the spotlight, and I mean the really bright spotlight, is on something entirely homegrown.
It's a pivotal moment. The atmosphere described in the reports is definitely different this time around. It isn't just about a new model year. It feels like a fundamental shift in the industrial landscape.
We're looking at the debut of the new fleet from Project Aero. And I want to be clear right off the top here, because I know how people react to concept cars. This is not just another flashy design exercise with gull-wing doors that will never see a production line. This feels like a statement. We're talking about a massive shift in Canada's industrial identity.
That is the key phrase, industrial identity. For decades, if you looked at the Canadian automotive landscape, we were essentially a branch plant economy.
Let's pause there and unpack that term, branch plant. It sounds a bit bureaucratic. What does that actually mean for the economy?
Well, on one hand, it means you have a strong manufacturing base. We have incredible workers, huge plants in Oshawa, Windsor, Oakville. But fundamentally, we were assembling other people's cars. We were building their designs, using their engineering, following their instructions. The decisions were all made in boardrooms in Michigan or Wolfsburg or Tokyo. Project Aero is the mission to change that dynamic entirely. It's about transitioning from being the assemblers to being, well, the architects of a zero-emission future.
So it's about owning the IP, not just tightening the bolts. And the names of these new vehicles, I mean, in our hypothetical 2026 scenario, they're just fantastic. We've got the Borealis and the Vector. They sound like something out of a sci-fi novel. But before we get to the shiny new metal, we have to talk about the name Project Aero itself. For anyone who knows their Canadian history, that name carries some serious baggage, doesn't it?
It carries a tremendous amount of weight. You can't really understand the excitement in that room in 2026 without understanding the heartbreak of 1959.
The ghost in the hangar.
Exactly. The original Avro Aero. In the 1950s, this wasn't just a plane. It was a supersonic interceptor jet that was arguably decades ahead of its time. It was a masterpiece of engineering, faster and more advanced than anything the Americans or the Soviets had. It symbolized what Canadian innovation could do when it was given a long leash.
And then the story takes a very dark turn.
It does. On February 20th, 1959, a day known as Black Friday in the aviation world, the government just canceled it. But they didn't just cancel the funding. They ordered the prototypes destroyed. They took blowtorches to these incredible machines. The blueprints were pulled. It was a complete erasure.
That feels so aggressive. It wasn't just, we can't afford this. It was, we're deleting this from history.
It was traumatic for the industry. It led to a massive brain drain. Canada's top engineers, the people who designed this miracle jet, they packed up and left. They went to NASA, to other U.S. aerospace firms, because there was nothing left here for them. So for decades, the Aero symbolized lost potential. It was the ultimate what could have been.
So naming this new electric vehicle initiative Project Aero is, that's bold. It's like they're invoking that ghost on purpose. It's almost a dare.
It is a redemption arc. That is explicitly how the reports frame it. But what's fascinating here is the difference in how it's structured. The old Aero was a centralized government military contract. It lived or died by the pen stroke of a politician. If the political winds changed, the project died. This new Project Aero is completely different.
How so? If the government isn't running it, who is?
It's a bottom-up collaborative effort. It's led by the APMA, the Automotive Parts Manufacturers Association. But they aren't doing it alone. It involves over 60 domestic suppliers, academic institutions, tech companies. It's not about defense anymore. It's about economic sovereignty and climate action. The idea is that you can't cancel a movement that's built by the entire industry.
Right. You can't kill it with one signature because it's distributed everywhere. It's a network, not a single contract. And that brings us to the most mind-blowing statistic in this entire stack of notes. When I read this, I had to double-check it.
I think I know which one you're looking at.
The 97% figure. The report says Project Aero boasts 97% Canadian content.
It's a staggering number. In the world of modern manufacturing, that is. That's practically unheard of.
Okay, let's unpack this. Why is that so crazy? Because I feel like most people assume if a car is built in a factory in Ontario, It's a Canadian car. Why is 97% such a big deal?
Because modern vehicle manufacturing is a global mosaic. A standard car you buy today, even if it's made in Canada, might have a transmission from Mexico, electronics from Taiwan, glass from China, and an engine block from Germany. It all just meets in Ontario for final assembly. To have a vehicle where 97% of the parts, the IP, the raw materials, and the software are sourced domestically, that requires a level of supply chain integration most countries just don't have.
So we're talking about everything from the chassis to the code.
Everything. The reports highlight a 3D printed carbon chassis, which is cutting-edge manufacturing.
Wait, 3D printing a chassis? I usually think of 3D printing for, like, small plastic trinkets, maybe prototyping a bracket. You can print a whole car frame.
You can, and it's a game changer for development speed. Instead of spending millions on tooling and molds just to see if a design works, you print it. But it's not just the high-tech stuff. This is where it gets really interesting. The advanced materials. They aren't just using standard plastics, they're leaning into Canada's natural resources.
I saw that they're using hemp-based interior panels.
Yeah.
I have to be honest, when I hear hemp car, I picture something a little crunchy.
It does sound a bit stereotypical, doesn't it? But biocomposites are serious science. Hemp fiber is incredibly strong and lightweight. When you mix it with the right resins, you get a material that can rival carbon fiber or fiberglass, but it's grown in a field, not synthesized in a chemical plant.
So it's lighter, strong, and sustainable.
Exactly. And they're using wooden accents that are a direct nod to the Canadian lumber industry. But again, not just for looks. Wood has excellent damping properties. It absorbs vibration. So it's high-tech, meeting the great outdoors.
That is so cool. It's uniquely Canadian engineering. But beyond just being a patriotic flex, does this actually make money? Because usually, buying local for everything is expensive. Global supply chains exist because it's cheaper. Is this economically viable?
That is the big question. And if the goal was just to mass produce this one car tomorrow, the cost might be prohibitive. But you have to look at the electric alley concept. This is the corridor from Windsor to Oshawa. The strategy behind Project Arrow wasn't just to build one nice car. It was to build a business card for the entire country.
A business card, so the car is a marketing tool.
In a way, yes. And the data proves it's working. We have some hard numbers on this.
Lay them on us.
The suppliers involved in Project Arrow, because they could prove their tech works in a real functioning vehicle, have already secured over $500 million in new global contracts.
Whoa. $500 million just from participating in this.
$500 million. And these aren't small players they're selling to. We're talking about contracts with Tesla, Ford, GM. These global giants are looking at the tech in the Arrow, maybe it's that hemp composite or a specific sensor array, and saying, we want that in our cars.
So by building this one concept car, local firms are winning huge contracts on the global stage. It de-risks the technology for the big buyers.
Precisely. It's the difference between showing someone a blueprint of a part and letting them drive a car that uses it. Here's the key, take it for a spin. It proves the component works in the real world. And this insulates the sector. If global supply chains break down, which we all know they can, we remember the chip shortages, Canada's built a resilient domestic ecosystem.
That is a massive win. It's not just about pride, it's about profit and security.
Yeah.
But speaking of things that are distinctly Canadian, we have to talk about the weather. Because anyone who drives an EV or even uses a smartphone in January knows that batteries in cold weather are frenemies at best.
Frenemies is putting it politely. It's more of an adversarial relationship. Range anxiety is the #1 barrier to EV adoption, and it gets significantly worse when you hit -30°C.
What's actually happening chemically there? Why does the battery just die so fast?
It's fairly simple chemistry. Inside a lithium-ion battery, you have ions moving through a liquid electrolyte. When it gets cold, that liquid becomes thick and viscous, like syrup. The ions just move slower. That means the battery can't release energy as quickly, and it can't accept a charge as fast. You lose power, you lose range, sometimes up to 40%.
And usually cars are designed in places where winter is just a concept, right? Like sunny California.
Exactly. If you design a car in Silicon Valley, -30 isn't really on your radar, and that is the born-in-the-cold advantage that Project Arrow is leveraging. The development was done in collaboration with Ontario Tech University and their ACE climatic wind tunnel in Oshawa.
The ACE climatic wind tunnel. That sounds like a villain's lair.
It's an incredible facility, one of the most sophisticated in the world. They can simulate blizzard conditions, extreme heat, hurricane-force winds. They can literally make it snow inside the tunnel while the car is running on a dyno. So the engineers didn't just hope the car would work in February, they tortured it. They developed proprietary thermal management systems that actively regulate the battery temperature.
So it's like a heated blanket for the battery.
In simple terms, yes, but very sophisticated. It recycles waste heat from the motor and electronics to keep the battery in its Goldilocks zone. Not too hot, not too cold. It ensures the car performs reliably even in a Canadian blizzard.
Yeah.
And if we connect this to the bigger picture, think about who needs this tech.
I'm thinking Norway, Sweden, Minnesota.
Exactly. That winter-ready DNA is now a primary selling point for Canadian suppliers. They can walk into a meeting with a global automaker and say, our tech works when others freeze.
That is such a smart pivot. Instead of seeing the cold as a disadvantage, they turned it into a feature. Battle-tested in Canada. And by that, it implies a ruggedness you just don't get from a fair-weather vehicle.
It's a badge of honor. It suggests reliability.
Okay, so we've got the history, the supply chain, the weather testing. Now let's fast forward to right now, our January 2026, the auto show. The report mentions a fleet. It's not just the one silver SUV anymore. We have the Borealis and the Vector.
This is the evolution. The original prototype was about proving it could be done. The 2026 lineup is about specialization.
Let's start with the Borealis. Great name, by the way. Very evocative.
Very fitting. The Borealis is the refined all-electric SUV. This is the consumer-facing vision. The focus here is on aesthetics and integration. They're trying to prove that a Canadian EV can compete with luxury brands on style. It's sleek, it's beautiful, and it shows that we can do sexy design, not just utilitarian engineering. It's meant to sit next to an Audi or a Lucid Air and look just as desirable.
And then there's the Vector, which sounds a little more mathematical.
It is, and for good reason. The Vector is a software-defined vehicle platform.
Okay, let's stop there. Software-defined vehicle, or SDV. We hear this buzzword a lot. What does that actually mean?
Think of it like the shift from a flip phone to a smartphone. When you bought a flip phone, you were buying the hardware, the buttons, the hinge. That was the product. When you buy a smartphone, sure, the hardware matters, but you really care about the operating system, the iOS or Android that runs everything. The value is in the software.
So the car is becoming a rolling computer.
Exactly. The Vector isn't just a car, it's a digital architecture. It includes the cybersecurity, the sensor arrays, the data processing. It's a skateboard platform that contains the battery, the motors, and the brain.
So they aren't just selling a car, they're selling the brain of the car.
That's the business model. Other manufacturers can buy the Vector platform and build their own car body on top of it. Say you're a startup EV company in Vietnam or a niche manufacturer in Europe. Building a chassis and a Level 3 autonomous driving system from scratch is incredibly hard and expensive.
So instead, you call Canada and buy the Vector.
Right. You buy the platform, you put your own hat or body on top, and you have a finished car. The Vector comes with advanced cybersecurity to protect against hacking, which is the new frontier of automotive safety.
That is where the industry is going, isn't it?
Yeah.
It's less about the steel and more about the code.
It is, and by showcasing the Vector, Project Aero is saying, we have the digital infrastructure to support the next generation of global vehicles. We aren't just bending metal anymore.
And the timeline for all this. Because seeing it at a show is one thing. When does the rubber hit the road?
The roadmap is aggressive but realistic. They're aiming for a commercially viable prototype by 2028. And this aligns perfectly with the federal government's goal of 100% zero-emission vehicle sales by 2035.
So 2026 is the showcase, 2028 is the prototype for production, and 2035 is the full transition.
That's the plan.
Okay, I have to ask the question that I know the listener is shouting at their device right now. The car looks cool, the tech is amazing, it's winterproof. Can I go buy a Borealis today? Can I put down a deposit?
The short answer is no.
Ah, heartbreaking. I was ready to sign up.
I know, it feels like a letdown. But it's really important to clarify the nature of Project Aero. It's an initiative, not a new car company. You aren't going to see a Project Aero dealership popping up next to your local Toyota or Ford dealer. They aren't trying to be the next Tesla. They are trying to be the Intel inside of the next Tesla.
So if I can't buy it, why should I, as a regular consumer, care? Why does this matter to my daily life if I can't have one in my driveway?
That is the crucial question. You might not be able to buy a car with an Aero badge on the hood, but you will be buying the technology inside it.
This goes back to that $500 million in contracts.
Exactly. It's called tech transfer. If you go out and buy an electric Ford or a Stellantis vehicle built in Ontario next year, there's a very high probability that the battery tray, the cybersecurity module, or those thermal sensors we talked about were perfected in the Project Arrow program.
So the DNA of the arrow is sort of invisible, but it's everywhere.
It's under the hood. And that matters because it means the money you spend on that new car is staying in the Canadian economy. It's supporting local high-tech jobs. It's ensuring that your neighbor who works in manufacturing or software engineering has a secure future.
It's about economic resilience.
Exactly. By buying cars with this tech, you are insulating the Canadian economy from those global shocks we mentioned earlier. If we're just assembling parts from overseas, we're vulnerable. If we own the IP and the supply chain, the plants keep running. The money stays here. It creates a self-sustaining ecosystem.
It's the circle of life, automotive style. You buy the Ford pays the supplier in Windsor, the supplier hires the grad from Ontario Tech.
Precisely. It turns us from tenants in the global automotive industry into landlords. We own the building now.
That is a much better way to think about it than just cool car I can't have. It's actually cool tech I'm already using.
And it changes the narrative. We aren't just the people who tighten the bolts anymore. We are the people who design the machine.
So what does this all mean for the future? We've gone from the tragedy of the 1950s Avro Arrow to the electric alley of the 2020s.
It means a shift in national identity. We're moving from assemblers to inventors of the future. The synthesis of all this, the history, the tech, the collaboration, is that Canada has created a blueprint for success that doesn't rely on Detroit or Silicon Valley. We did it on our own terms.
That image of the Borealis and Victor sitting there at the Metro Toronto Convention Center, it's powerful.
It is. It's the physical proof that we can lead. It's a declaration of independence, in a way.
And unlike the 1950s, nobody is coming to crush the prototypes with a bulldozer this time.
No. As one of the reports beautifully put it, this time the arrow is staying in the air.
I love that line. The arrow is staying in the air. It really captures the redemption arc. It feels like we've finally closed that chapter of what if and started a chapter of what is.
And it opens the door for so much more.
That's actually where I want to leave our listeners today. We spent this deep dive talking about cars and batteries and software. But think about the model here. Collaborative independence. A 97% sovereign supply chain. If Canada can build a 97% sovereign vehicle, something as complex as a car, what other industries could we apply this to?
It's a provocative question.
Could we do this for our energy grid, our food systems, our medical technology?
If we can secure our automotive future against global instability, why not secure everything else? It's a template that could work across the board.
Something to mull over the next time you're scraping ice off your windshield and wishing your car had a thermal management suit. Thanks for diving deep with us today on Project Arrow. We'll catch you on the next one.
Goodbye, everyone.